Hi, it's so nice to be here. I'm so excited. As mentioned, thank you very much for the kind introduction. My name is Mariko, and that's my Twitter handle. I just tweeted this link to this slide, although you may not have any problem with this much big screen. But if you want to have it on your lap, I tweeted the link to the screen. I work at a company called Scripto, and my title is textile engineer, although I don't do that for my day job. My company makes a software for TV shows, collaborative writing, a lot of text, but they let me choose my title based on my side project. One of my side projects is a meetup called Brooklyn.js, which I co-organize. If you're ever in Brooklyn on Thursday, please come visit. We have a lot of media folks down in New York, so we get to discuss a lot of data visualization as well. And my favorite data type is an array. I really, really like array. I like mapping them, I like deducing them, but I like to do that on a physical scale. So I like mapping and deducing the array that's on the needle of a knitting. And I have a whole bunch of research about how knitting is coding, and if you're interested, I'm more than happy to talk about it. But I got really interested in doing physical array that I even wrote a programming language, a domain-specific programming language to make a textile pattern for knitting. It basically outputs array. And I put the array into a software to visualize it better. And I put it back into the machine and knit something like D3 scarf. It's visualized in D3, took it into JavaScript application, took it into array, which ran in a node that's communicating to machine. So it's all the way to JavaScript. I'm a JavaScript developer, if you cannot tell. And sometimes the request comes in, and I kind of make a scarf out of this was Travis CI's API usage. I gifted to the Travis CI. So this is what my weekend desk looked like. It's code, visual, graphics, and then machine and yarn. And that somehow all makes sense to me. And this kind of started heavily a year and a half ago. So I had a problem, or I had a journey to take. I wanted a cute cat photo on my jumper or the sweater or anything I want. I wanted to make that happen. And I realized that my knitting machine only takes, well, first of all, knitting machine is only 200 pixel wide, so I have to resize the image. And yarn doesn't come in hex color, so I have to figure out all kinds of image processing, essentially. And I go into Google things and then, find a wiki page and, the research from university. And, I just want to take this cat image into yarn. Can I please do that? So it was a lot of frustration. And I, discovered that I can do that on Photoshop, but also Photoshop is frustrating. I don't understand what those buttons and lines do. So I got a question that, can I make that all happen in the language that I use every day, which is JavaScript and HTML, and do that in the software I use every day, which is a browser? And that's kind of started. And yes, I can. I can use something called Canvas. Canvas is designed for that. Even on MDN, it says an HTML element that can use to draw graphics using JavaScript. So for next 25 minutes or so, I am going to talk about how I utilize Canvas to do various image processing. My primary interest is printing out a blanket, but I promise that you will take away something useful, hopefully, for your data visualization, for your web application, something to take away. If you are image processing professional, this might be very general. I might be generalizing stuff and maybe basic, but bear with me. So let's talk about Canvas. Canvas, you can create a DOM element and give a size, width, and height of things, or you can just create an HTML tag and then reference it by ID. But creating Canvas itself is like buying a piece of land, but you don't know where that land is located. You need to give something called context in order to understand where this is located and what kind of building you can build on. So you can give a context like WebGL, used for a lot of 3D and heavy computing stuff. Or you might be, giving a context of 2D, which is very flat, and you deal with a lot of, graphics. Nonetheless, giving the context gives the canvas a set of language you can communicate. You might speak WebGL, you might speak 2D, you might speak New York accent, you might speak Boston accent. It's the same thing, just giving a context is a set of language. So for entire example, I'm going to use 2D context. So once you establish the context, you can use a human readable language like rectangle, put the rectangle in, or even get the image from other parts of HTML and draw an image. But I like data and I like array. So the canvas has a thing for that. Canvas can communicate with you by data using getImageData and putImageData method. Basically, the getImageData, get the data out of your canvas, and you do magic happen, and then you put the image data back in using putImageData. So for the example that I'm going to show, this is the process that I'm taking. You have some kind of image, you create a blank canvas, you don't know where it is yet, you give a context of 2D, so now you have a set of language, and you load that image into that canvas. Now you have that image in the canvas, you can get the data out and do some cool things, and then put the image back in. So what does that data look like? When you call a getImageData, that returns an object called ImageData. What does that look like? So this is what image data look like. Some of them are very straightforward. Width and height is a width and height of the image. So I have a 3x3 very small enhanced image. But then there is a thing called data that has a bunch of numbers. And I don't really understand what this is. Like, how do I understand this? In order to understand what this data is, you need to understand what's in each pixel. So let's look at this pink square. So, oops, did the animation. Let's imagine this is a single pixel. It may or may not have googly eyes, but it's certainly fun to put googly eyes. Underneath of a single pixel, you have 4 numbers associated with pixel, and all of them are between 0 to 255. First 3 are light bulbs illuminating at different level. So this is a red, green, and blue value. You may know RGB value. So you can change those to change the color. It's just, what level the 3 light bulbs are illuminating. And if you have an equal number for each 3, you always get gray. And this is how you grayscale an image. If you get the 3 colors in, do whatever the math, average, take a green, Lumerscape, whatever, just put the same number for 3 colors, you get the grayscale in. And the last number is purely for software, which is opacity value. So if I have lower opacity, then transparency. This is for canvas to know how much of the color to blend it in if 2 elements are overlapping each other. So if with this understanding, you can see the image data like this. I pad it with like chunk of 4, and each of them, first 3 are color light bulb, and then last one is opacity. So if I change the first one, which is the lit light bulb, to 255, which is a max, and turn down green and blue light bulb all the way, and update it, then the pixel will turn red. So that's how we are going to manipulate the image from now on. So, but this image is one-dimensional array, and you have information about width and height. How do I know XY coordinate of these pictures? Well, I like to think of it like writing a letter on graph paper. So if I'm thinking about writing a letter to somebody, the data that's coming in my mind is a stream, and it's that one-dimensional. But the output itself has a dimension. Whenever I run out of a space on the paper, I line break, and then I go to the next one. So that's how this pixel works. In code, you might see something like this, the double-nested loop. The outer loop goes through y-axis to get to all of the y-axis. And then the inner loop goes through horizontally to get xy coordinate of stuff. And each pixel has 4 numbers, so you need to calculate the index of stuff to get to each addressable data. So even if you have those numbers, you can have fun project like this. I created this project called Ghost Image. It is a 1x1 pixel div that has a whole bunch of box shadow to create a illumination that you have an image here on that corner. This is actually not an image tag, it is a box shadow with 1 by 1 pixel. Not really practical, it's used a lot of memory to operate, but certainly fun to kind of plunk people. So I got all the data in, I know how to edit the stuff. Can I do image filters like Instagram? And I kind of, started to research about it. And I stumbled upon this. Like, everybody was talking about math. And, I don't really talk math. I don't write squiggly function. I like function and type, So I like to think of it as, kind of like playground. And the shape of the slope in the playground determines what kind of filter you get out of. And this is a data visual conference, so I created a visualization of this slide. So this is the original slide. If you have an input of 128, output is 128. Let's invert this image, invert photo. It's quite literally inverting the slope. So now if I have a higher value, you get the lower value out. If I have a lower value, you get the higher value out. And this is how you invert the image. Brightness is shifting up and down the original slide. So if I brighten the image, all of these numbers, that's like 138 to 255, it gets just fully on all of the illuminated in the light bulb. If I do move that down, then it gets darker. The contrast, I'm the kind of person who guesstimate the contrast and brightness value on the Photoshop until I'm satisfied with things, up until I understood what contrast does. Contrast is a slope of that slide. So if I change the low slope, that's a low contrast, meaning the input is coming from 0 to 255, but output is limited. So you get a low contrast of color, and high contrast is the opposite way. It doesn't have to be a straight line slope. It can be step and creating a posterize effect, and you can limit the color that you use in the image. Or you can do something like solarize, which is a high contrast on the two sides and then inverting on the middle. So creating kind of colored negative photo kind of cool effect. And if you take a grayscaled image and put the two-step on, you can do the threshold in image. And I'm pretty sure a lot of image processing and computer vision use this as a first step to get to a usable data set, so you can kind of locate where things are. And taking those grayscale data, you can also, I know rainbow pseudo color is not recommended, but you can see why if I graph it this way. So rainbow colors are not recommended because the blue steps are very harsh, but then on the green steps, it's kind of like you can't really tell the step. It makes sense. The green is fully on the longer than any other color, and our eyes are more receptive to green. So you can change that lines to create a different pseudo colors to give a color to your data set. So these techniques are not only for creating Instagram filters. I had this challenge of taking old data, so I don't have any coordinates or any data points, I just have an image from archive, and I wanted to create an interactive map. How do I go with that? Well, you can do things very basic, like creating an A tag and styling in CSS and making it box, and it doesn't cover other parts of the Boston, but it's kind of not accurate. You can use HTML5 map element and draw the polygon to kind of get it right for, send to Boston to have some kind of click event. But if I want to do the pixel perfect click event, then I can just put it into whatever the image editing software that I have. I put it into my iPad, and I draw the line, and then I fill it with white, and it literally took me 15 seconds. I grayscaled it. Now, fully white pixels are the target I want. So I threshold it. So now I have a reference map of if the click coordinates go there, and if the pixel is black, that means do not trigger the click event. If it's white, then trigger the click event. So I have basic function, and the hidden canvas has this threshold image. So whenever user clicks something, and it doesn't have to be overlapping each other directly, you can just live in the memory, but just for the reference, I have it overlapping. Anytime user click events goes in, I call the reference, is it black, white, and then trigger the event. So you can use image processing technique not only for creating a pretty photo for Instagram, but you can utilize it for interactivity. So it got me interested in, like, now I can control color. Can I change the shape of image, like blur and sharp? And again, and this keyword got mentioned today in the 2 talks in the morning, the kernel convolution. And to me, it was like, that sounds yummy cereal. I don't know what that is, but cool. The math itself, although wasn't too complicated, but explanation was very complicated. So I'd like to think the kernel convolution as a pixel social graph. It's just thinking about a relations of pixel. Let me explain. So you have a single pixel that you're going to change the color of, and it's sometimes called kernel. You have a friend surrounded by it, and you create a convolution matrix. Now, in the case of blur, this center pixel wants to blend it into your friend as much as possible. I don't want to be noticed. So you give a number to each of the friend. You combine all the color, divide it by sum of this number, so in this case 9, and then you get new color for this pixel. How does that look like in the bigger image? So I have this very vivid pink line going on. We learned that each pixel have 3 colors. So we do that for 3 channels, get the one number for red, get a number for green, one number for blue, and then do that for all of the pixel one by one, and then you get a blurred image. And that's how you do the kernel convolution, or I would like to call it pixel social graph. So the blur that we just did is called box blur. It's, every pixel is equal. This is the original image, and it's subtle, but you get blurred image. But in reality, your friends are not as equal. You have a close friend, and then you have a distant friend. So you can have Gaussian blur, which is a close pixel get more higher number, and then the distant pixel gets a lower number to create more edge-preserving blur. And this makes sense to me. As a web developer, I always wondered, when I make a filter in SVG, I have to type FE Gaussian blur. Why is it not just blur? Turns out blur has a different kind. So now I know. The sharp is the opposite. You do not want to blend it into your friend. You want to be unique. You almost run out of opposite of your friend. So you rate yourself really high, and then rate your friends really low, and do the same thing to get a sharpen effect. And maybe it is, yeah, sharpening. So I use this technique to create a fake tilt shift application. So if I put an image in and then specify the area or something, and then start processing an image, then it the area gets blur, and then making a fake tilt shift effect. This was one project, but this taught me another challenge that I would encounter if I were to use this in a project. In the project, the performance matters. And exporting the image, I do all the image editing there, but it lives in the canvas. And what if I want to tweet, or what if I want to share on Facebook, want to export an image? So there's a 2 things that need to be addressed. And I'm going to go through that in rest of the minute. So the performance gets really slow. And because JavaScript is single-threaded, that slow process blocks your UI, the click events and everything. And you can go by making it faster by using faster algorithm, better function that you write. But inevitably, you're doing a lot of calculation on image. And if you want to use a original image, 10 meg that comes from your phone, then you will have problem with blocking UI. And you can use something like web workers. Web workers are a way to learn your JavaScript in the background thread off of UI. What does that mean? I like to think of that as a web worker is International Space Station. If you think of the Earth and DOM as a Earth, so browser and DOM is in this Earth. It shares the UI thread. It's like all the elements are here. You launch the International Space Station. You can talk to the data, but the web worker, the International Space Station, cannot touch the element on the Earth. So web worker does not have access to the window object, or you cannot use jQuery select inside of web worker. So how does this doing that in code looks like? Quite simple. It's just that. So let's go through one by one. So launch a web worker is literally just typing new worker and giving a file that you want to execute in the worker thread. And that's like launching an International Space Station. I mentioned that the web worker does not have access to window or DOM. So even though you might be having underscore some utility library in your main thread, you need to leave require again if you want to use it and use that as an import script. Once that's done, the communication between main thread and worker thread are done by post message method and then on message event. So while the main thread is taking care of click events and all of the UI elements that you want the user to use, you can push off the expensive calculation off to the worker side. And once the data comes back and you don't need a worker anymore, you can just terminate. It's like sending the ISS to the black hole and, you know. So, oh, the video is not loading. Okay. So I created a demo, simple demo of a tilt shift that I showed just now. I have the demo that's running on the main thread, and then I have a web workerified version of stuff. And I kind of explicitly created an animation by JavaScript. So there's a color box that's moving, that's controlled by JavaScript to kind of hijack the event. So once I run that, the event starts. Immediately, the main thread one, the UI freezes, doesn't respond to any of the click event. The web worker side is responding beautifully and doing so. And in the minute it finishes, it's like nothing happened. But in the main thread one, it finishes, and then it just executes all the click event that was accumulated, and then it just junks up all of the UI. So you don't want that in your visualization if you want to do that. So performance is kind of taken care of. Let's think about how to export. Like you might want to put it into PDF to send it your report, or you might want to tweet. There are two ways to get data out and save it as an image from Canvas. And one is to data URL and to blob. And there's two use cases for that. So the easiest one is to data URL. Calling to data URL on Canvas returns a basic default text representation of an image. So you can directly use that in your CSS, or you can put that into href in your element and create a download button. However, so let me show the example. So I have mentioned that I created this programming language for knitting machine. So I have a little parser running on the background. Every type I do, it is running the parser again and returning the array and creating a canvas here. So the canvas is just little tiny corner. And every time I change the canvas, it's calling the toData URI and getting a base64, put it into CSS and letting the CSS take care of all the background tiling and stuff. So I don't need to worry about. And I can just click the download, and I don't know if you can see it there, but yeah, that's like ugly base64 URL literally in the href. So that's how I use base64. However, it's expensive if the image is big. Like any web, like base64 image text is expensive. So you want to avoid that. And also the href itself, although I couldn't find it in spec, as far as I know, the HTTP spec does not restrict the length of what's going into the href, but the browser vendor restricts it. And that seems to be around 2,000 characters. So if you're dealing with small image, you can get away with. But if you're trying to do image with like a meg or something, you will have problem with creating download button. And you can use something called toBlob. So toBlob makes a binary large object, which then you can pass into method in window called createObjectURL. And you can just use that image for your download link. In either case, you need to specify what kind of image format you want. And this got me thinking, that I need to specifically say, I want this format in this compression. And I was like, I actually don't know how image works. Like, I know GIF is animation, PNG is like everything, and JPEG is like what comes out of phone. But I actually don't know, like I don't have any like sophisticated knowledge to decide on which one is the best for my data visualization. So I did a little research. GIF limits the color to 256 colors. You cannot use more. PNG and JPEG use the 4 colors, although PNG can specify the paletted mode and use like a GIF. The file also tends to be smaller on GIF and JPEG and larger on PNG, although if you set a palette mode in PNG, it's almost always smaller than GIF. And the transparency, the JPEG cannot handle transparent pixels. GIF only handles fully transparent or like fully opaque. PNG can handle kind of variety of things. And the compression-wise, PNG and GIF is lossless, meaning once you compress it and decompress it to show it, you can get the original state of the data. JPEG is lossy compression, creating something called JPEG artifact on the way. So this is just a handy chart of how to get around. In any great web question, it starts with, is it animation? And if not, is it graphics or photo? And then you can kind of decide on the image. So I discovered after researching this is why Twitter picture looks so shitty. So Twitter use JPEG compression no matter what your original input is if the image is fully opaque. However, remember, JPEG cannot handle transparency pixel. So if you put a transparent image in the Twitter, then it will use PNG and it will not create a JPEG artifact. And I learned that from somebody that created a tool to just upload your image, and it's just fully opaque image. And then you can't even tell. There is like 1 pixel on the top left corner that is turned 99.6% transparent, so that Twitter's perspective, it has transparent pixels, so it's going to default to PNG and preserve your Twitter image. You're welcome. So all of that are open sourced. I have a little JavaScript utility library called Graphy.js, which kind of I try to aim it for like underscore, but for image data. So you can kind of prototype stuff. It is not smart. It is not clever code. It is very slow. But the point was that I had so much problem understanding those high-level sophisticated system, and all I needed was basic concept of how image processing works. So the code is very simple. However, it is meant to be, and encouraged to look at the source code. All of the examples, links are there. And I have a googly eyes if you want to. Thank you very much for OpenVis. This conference was, when I started, I watched all of the video from OpenVis to learn how to D3 and how to do the data visualization. I came here last year in person. That was amazing. And now I get to talk here. So thank you very much.